Hey everyone, thanks for attending our February webinar. Today we'll be talking about building calibration labs and hopefully giving you a roadmap to accreditation and demystifying a little bit about what accreditation really means. Today I have with me three excellent panelists. First is Michael Johnston, who's a software portfolio product manager at Fluke. He has extensive experience in calibration, metrology, measurement uncertainty, and all the skills are really honed at Northrop Grumman, Simcoe, U.S. Army, and of course here at Fluke. He holds a BS in applied mathematics from SUNY Empire State College. With me also we have Wally Miller, who has 40 years of experience working in the test and measurement industry and 25 years in metrology. At Fluke, he's held a lot of different positions, from international sales management to engineering to his current role as electrical calibration product manager. And lastly, but not least, the person everyone here is probably here to see, we have Jeff Gust, who's our chief corporate metrologist here at Fluke. He was a calibration laboratory accreditation assessor for 10 years prior to joining Fluke. He also is a member of the board of directors of accreditation bodies and a service consultant and trainer to these accreditation bodies on metrological requirements. He's currently the chair of ILAC Stakeholders Forum and a member of the ILAC executive community, and has been part of the writing groups for ILAC P1007 2020, as well as which is the ILAC policy on metrological traceability of measurement results. He was also the writing group member for the ISO 17025 and the initial version ISO 17043, which we will discuss here shortly. So quickly to get started, why should you seek accreditation? When I'm out in the field visiting customers, I always hear the question every single time. It's my technicians all have DMMs or other measurement equipment, and it's really getting expensive to send them out to be calibrated. Where do I start, and how do I ensure my lab is accredited?
Well, can I start that, Jeff, and ask a little bit about why? Because it's part of why is there's part of that I believe it's a little bit of a a commercial question, because when you look at accreditation, what it's really trying to, if you look at somebody who's accredited, what you're really doing is you're getting a perspective that person has gone through some sort of process to vet the work that they do and the job that the calibrations that they're performing. So it's a little bit of way of sorting out somewhat who or the quality of the vendors that you have. There's a lot of people that can perform calibrations, but the ones that are accredited or have accreditation behind them, they've had somebody outside of their organization look at their work and basically state that what they're doing is quality and quality work. So I mean that's part of the reason why I think people look for accreditation is that it's a way to sort out who's doing a good job or who's authorized and there's some standing behind them saying that they're doing things properly.
Yeah, I think you're muted, Jeff. Yeah.
Sorry about that. I was going to say, Mike, do you want? I've got a couple of thoughts, but would you like to jump in?
Yeah, sure. Yeah, I think that, like Wally said, a lot of it comes down to quality, and so for every accredited lab, I think there's something like 7 to 10 unaccredited labs, right? So there's certainly not a requirement to be accredited in order to do calibration, but when you have a set of requirements like we have in ISO 17025 that tell us, right, from a quality perspective, what things we should be doing to ensure that our work is of a level of quality that's acceptable. And then we have a way to basically confirm through an outside party that the way we are doing our work is adhering to those types of standards. That gives us a level of I guess, reassurance as an outside, user that that's going to happen. And so it's kind of I guess you could say like a badge of honor or some kind of, very clear indicator that there's a level of quality built into the process there that gives a good starting point to judge from.
Yeah, and again, kind of echoing a little bit with both Wally and Michael have said, and going back to the question about, hey, it's really expensive to get them accredited calibrations. Why is that, or how do I start and ensure that my lab's accredited? It's really, as Michael said, that is that the process of accreditation is a voluntary activity. You don't have to be accredited. And there are a lot of fine laboratories that are not accredited, and there are some not so fine laboratories that are accredited, honestly, out of that process. But what should be driving your business decision, as Wally had said about becoming accredited, should be based on your customers, and your regulatory environment that you're in. There are a lot of countries where the government of that country had said, in order to accept calibration or testing results, you have to be accredited, or your customer specifies, I want an accredited cal. That's what I want to pay for on this. So if you're not accredited, well, then you're going to miss out on that opportunity with that customer as well. So again, General Motors back in the 90s was probably one of the first people to drive this when there was a standard called QS 9000 for the automotive industry. It was kind of the ISO 9001 answer to, the automotive's answer to ISO 9001. And in that document of QS 9000, they said, if you're an external calibration or testing facility that does testing results, you must be accredited to ISO 17025. And that was probably the big trigger in the United States for really driving accreditation. And that standard also became morphed into ISO 16949, which became the international standard for automotive manufacturing quality systems. So it's used all around the world, and the same requirements go into that as well.
Yeah, thanks everyone for that insight there. I think as we know this, to be accredited and to go for accreditation really goes down for everyone's quality and regulatory needs. And with all these accreditations are really governed by certain bodies. I guess, Jeff, with your experience here, what is the role of governing bodies in accreditation?
Okay. Oh, okay. That's a great question. So I know that so there in the United States, there are 5 accreditation bodies. In a lot of countries around the world, there's only one accreditation body in their economy. So it kind of depends on where you live and play. But these accreditation bodies are a part of what we call ILAC, which stands for the International Laboratory Accreditation Cooperation, MRA, which stands for Mutual Recognition Arrangement. So these accreditation bodies themselves have to be evaluated for their own competency to make sure that they can assess laboratories properly. But once they do, and they assess a laboratory, they accredit the laboratory to ISO 17025, what that means is that your calibration or testing results from that laboratory can be accepted anywhere in the world. The goal is test measured once, accepted everywhere. That's kind of the tagline of ILAC, and it's a really great thing, because back in the 1990s, for example, before the MRA came out, when Fluke would build a calibration standard and ship it to, say, Europe, we would have to pay to have it calibrated in Europe because nobody would accept the calibration results from the United States in Europe, and that caused a lot of delays in shipments to customers, and it cost a lot more money to the customer to get something calibrated twice that added no value. So now we have our NAVLAP accreditation in our primary standards laboratory in Everett, or A2LA accreditation in our service laboratories and our laboratory in Phoenix, that allows us to have global recognition of our measurement results.
Yeah, Jeff, I just kind of want to reiterate on a point there. I mean, it's it's the mutual recognition of accreditation that's critical. I mean, Jeff was talking about how for a while there we had challenges with shipping product into different legal geographies, legal entities, and being recognized. There was a period of time here at Fluke where we actually had 2 accreditations. We had a U.S. recognized NAVLAP accreditation, and then we also had the PTB come over and give us a DKD accreditation. And we would, depending on where we would ship the product, we'd choose one of the 2 accreditation bodies or accreditations on our certs, and hope that it would be recognized and acceptable in the geography that the product ended in. And those periods of time, it was really a challenge to keep both of those accreditations current and running, and a lot of expense as well. Because we had different auditors that would come through at different cycles, they'd have different requirements, different assessment things, and it was just, it was unusual. But we were one of the few, I think, one of the few organizations that had multiple accreditations in the test and measurement industry at the time. But that was also because of our business, and we being the a strong provider of metrology. But it was a challenging period, expensive as well.
Yes.
Yeah, so I think we have really discussed a little bit on the importance of accreditation and the governing bodies and how to really start your accreditation process, and what some of the questions that you need to ask and how it helps drive quality for your business. Having discussed this, I really want to start and move on to understanding the process behind it and the standards that really shape it. So panelists, can you shed a light on the accreditation process and the standards labs that calibration labs must adhere, particularly focusing on ISO 17025?
Okay. Michael, would you like to start this time since you didn't get
sure. Yeah, I was ready for Wally to just take over. I'm good with it.
Yeah. We'll share.
I think that a lot of the accreditation process and ISO 17025, it's about doing what you say and saying what you do, right? And so it's confirming that we have a quality process, we have a quality system in place, and then that we're adhering to that system. And so really one of the first steps is to define what that quality system is that you're going to enforce, and making sure it's sufficiently documented to be able to go through that process. And 17025 does a great job of outlining the specific requirements of that. But I think, even beyond that, there's a need to understand all of the moving pieces that have to be accounted for in that workflow of running your lab, and making sure that as much as you have it documented, it is being followed. And so that's really the 2 pieces there, I think, when you're starting that process.
Great. Michael, you make it sound simple when you say, document what you do and do what you document. But I've seen lots of labs stumble with, ensuring that you've got those 2 pieces in place. I mean, no processes that are off, in an undocumented form that come back and you go, oh, that's what we need to do. I mean, so I've seen a lot of folks struggle with that it sounds simple, but doing what you documenting what you do is a lot of work, and it takes a fair amount of rigor in your systems and your process to ensure that's being done. And I think a lot of the things that auditors are looking for is, do you have that rigor? Do you have those processes defined, and are you following them? So again, I think it sounds simple, but there's a fair amount of work that needs to get done there in order to actually do those 2 simple things. Document what you do and do what you document.
Yeah, and kind of adding on to that, so that is part of the process, because this part of 17025 contains the requirements of ISO 9001, and I've always kind of agreed with what Michael's saying, that ISO 9001 is do what you say and say what you do. But the downfall, or the kind of the negative part of ISO 9001 is it doesn't address technical competency. So, you know, if you wanted to be registered to make life jackets out of concrete, as long as you said how to do it and followed your process, you could be registered to make life jackets out of concrete. It wouldn't really help anybody, I guess, maybe unless you're in the mafia. But
Sure, I can find a business for it.
But the title of ISO 17025 to me really says it all. So the title of ISO IEC 17025 is the general requirements for the competence of testing and calibration laboratories. And unlike ISO 9001 that just says do what you say what you do, this standard is about technical competency, being able to produce a technically valid test or calibration result. And that's what makes it so special and so important in either calibration or testing. So the testing laboratories that would test your blood for cancer, or would test a crime lab to identify a criminal, use the same standard as we do for calibration laboratories, and that's has a lot of weight. That's a really important thing for us as well. But the document itself, it's not magic. It's not you know, anything that a lot of us don't already know already to start with. It's just good practices for running a calibration laboratory. But the difference is that you really need to be able to understand them, and you need to do them consistently. In the old days before 17025 came around, a lot of these practices we understood in the laboratory, but we'd say, oh, well, you know, I'm really busy today. I don't quite have time to go do this little function, so I'm just going to kind of skip that for the day. 17025 requires you do that all the time, that you live these requirements day in and day out, and that elevates the level of quality for our customers. That's what makes more value into calibration certificates. And I've been associated with a lot of laboratories that went through the process of accreditation, and I can say that it made every one of these laboratories a better organization as a result of this process as well.
And I think one of the key things too, Jeff, is a lot of these areas, 17025 is not prescriptive about the way that you're going to do this, right?
Yes.
It's about the fact that you have decided a way to do this and that you're following it. And so the one I always think of is temperature and humidity, right? Monitoring your environmental conditions. It doesn't tell you what those limits need to be.
Yes.
It tells you that you need to have limits and be, you know, monitoring those limits and having actions that occur when you are outside of those limits. Not even what those actions are, but having actions that are defined.
Take the right action. Yeah.
Exactly. Yeah. And so that's another big piece of it, is identifying for each of those areas what those requirements you are going to set and follow for your own lab are going to be. And there's, you know, tons of information out there in terms of best practices and, you know, the blanking on the recommended practices that you can leverage in doing that. And so it goes beyond, you know, just the requirements of that. You have to set your own requirements that then align with those core processes.
Yes, you're absolutely right on that. And one of the things you said it really resonates too. This is not an audit document. This is not a check the box kind of a process. This is where you have an assessor who is a technical expert in your field of calibration, not just any field of calibration, but knows what your technical scope does as well. And they assess you, they evaluate your competency to do it. And they don't say, did you control temperature, humidity? Yes, no. They say, what limits did you set for temperature, humidity, and how do you control it? And what do you do if you're outside of those limits? Because then they can evaluate your technical correctness in your procedures and processes. And that's really it drives some people a little bit crazy, because they all want everything to be exactly black and white to say everybody is exactly the same thing. But the reality is that it depends on the situation, and follow the science, you know, that has to come into play for the particular measurement process. How does does temperature and humidity affect it, or maybe not at all? Maybe it's vibration that really affects the process that you need to control, or maybe it's the electromagnetic disturbances from the power grid that's affecting your processes. So understanding which environmental parameters is really, really important. And you also said, and I think Mir was also saying, how do we get started? Well, the first step is to get a copy of 17025 and start reading it. But a lot of people get really confused by that. So there are great professional organizations out there that have lots of good training materials on this. Again, Fluke has great other webinars that are available on demand in our library to apply to different portions of ISO 17025 of how to address environmental requirements in the laboratory. So you can learn from that, but go to the NCSL conference or the Measurement Science Conference or the AOIL conference in India or the CFM conference in France. There's lots of good technical conferences with good knowledgeable people that can help share the way, and Fluke is a part of that too, where we have good knowledge and practical experience where we can help provide a little bit of guidance through this webinar series on that.
Yeah.
In my experience, and not just outside of the U.S., there's a fair number of national laboratories in some of these far-flung places, and they do have pointers and places to go to help people become accredited. So if you're in Mexico or in Canada, you could take a look at what their national laboratories are recommending in terms of places to start with accreditation as well. Again, I want to second the NCSL or those other local organizations that provide really good places for folks to get started. And there's a community. I don't know of a metrologist out there that isn't willing to help another metrologist in terms of making them better or improving their own process, because you always learn something when you talk to somebody else that's doing something similar to what you do.
Yeah, I was going to say, Wally, it benefits the industry as a whole when we have accredited labs, right? We have labs that we know we can rely on. A lot of labs can't do all of the work that they get on their own, and they need to understand, where to send that work to, that they can trust and rely on them to do a quality job that they can put forward to their customers and say, yes, we know that this work was done in the way we would expect. And so it's a benefit to all of us that we enable this to happen.
Absolutely. And to your point as well, it's good to make sure that we refer that you don't have to be accredited depending on your customer base. So Lockheed Martin in Colorado makes satellites that go up into outer space, but their customers don't require accreditation, but they follow ISO 17025 is not an accreditation standard. It's a standard for competence of running a calibration or testing laboratory. So you don't have to be accredited to follow 17025. It's a great document just to use in your laboratory every single day. And a lot of companies will use that as the basis of their quality system for calibration, whether they decide to get accredited or not.
Yeah. And I think all these resources that we had talked about, we will definitely share with all the attendees in our follow-up email. And I think there would be some great resources. And obviously, Fluke will be present at NCSLI later this year and MSC in March if you really want to come and talk to us about how Fluke can assist you in the accreditation process and how we can help you achieve the needs of your laboratory. And just kind of quick announcement, we will be doing a Q&A at the end of this webinar. So please submit your questions. I've seen some great questions come in already. But one thing I think that we touched on here was how labs are really getting started, right? And what are the steps that labs can do to take accreditation? But how do labs ensure ongoing compliance with these accreditation standards, and what challenges do they typically encounter during the accreditation process?
Okay, no, that's great. Somebody else want to start? Wally?
Again, I think there's a little bit of a hesitancy with what folks, if they haven't done this before, just diving in, because there is a large volume of information. And at one point in time, I'd read the standard too, and I shouldn't say one time, but as you read that standard, there's a lot of nuances and bits and pieces in it that kind of make you question, do I really understand what it's talking about, or is there something else here that I need to look into? So, I mean, I think that's the, you know, the sticking point, I think, with getting started with many is just it's a large volume of information to kind of get started. And, you know, I think that the best way that you get started is just a little bit at a time to get started. It's kind of like, how do you eat an elephant, one bite at a time, until you're done. But that's the process.
Michael, thoughts?
Yeah, I especially coming from the software side of things, you know, and trying to be agile and approach things, you know, a bit at a time, definitely resonates with me, Wally, what you said. There's great opportunity to expand your scope of accreditation in the future, right? And so if it means that you start with one specific area of your lab to get started with, and that's where you focus your efforts in the beginning, that's a good way to start. And then you become more comfortable with that process. You learn more about all the requirements. Maybe you find some things you need to address, and then you address those, and then you can expand that. We went through a audit when I was working in commercial Cal, and we were, I think, tripling the size of our scope of accreditation. And that was a ton of work to get ready for that. That was my first time dealing with accreditation. And day one of our audit, the assessor came in, and we were planning to, I think our scope had our 5520 as our like main, you know, DC and LF standard, and we had a 5700, and he's like, well, why aren't you using that? And so over the next like 18 hours, I got to redo all of our DCLF budgets to then replace it on the scope, you know, during the course of that audit. And so there's a lot of learning opportunity as you go through it to make those changes down the road, and start small and work from there, right? Focus on your specific customer who wants accreditation. Okay, where is their work at in my lab, right? Maybe it's just physical dimensional. Great, start there and then expand.
Yep, that's really good advice, and I've done that several times with my own laboratories as well. Start small, learn how to do it well, and then expand the process. And you can quickly expand and grow your scope as you go, but starting small is a really great way to go at it. A couple of things I think about sustainment, you know, Mayor's question on this that kind of resonate with me on this too is that number one, I think that one of the problems a lot of people have is they don't properly resource the sustainment of their 17025 quality system. So the lab makes a great big push and gets ready and gets through the assessment. And as soon as the assessors leave, they go back to doing things the way that they've always done it, and they don't live the quality system. Then 2 years later, they're ready for the reassessment, and they're freaking out and saying, oh, look at all the stuff we should have done 2 years ago. So making sure that you're building a culture to live it every single day is really, really important for that. And the question about what is the biggest challenge, I would probably say as an assessor and as someone who's worked with accreditation bodies and trained assessors, that the single biggest challenge is measurement uncertainty, because measurement uncertainty is tough, it's intimidating, and it's hard to do, but you have to be able to understand uncertainty because it's critical to your path of measurement traceability. You need it when you're making conformity assessment decisions, and quite simply, measurement uncertainty is the quantification of the quality of your measurement result. It tells people how well you actually perform the measurement and is it fit for purpose. So that's learning, getting more education around that, or using good software that's out there that we'll talk about, I'm sure, in a minute, is a great tool to make that a little bit easier for you, is a really important activity.
Yeah, Jeff, that's that's kind of really exactly where we're going, right? So I think we've explored accreditation process, the standards, and we know that managing that compliance can be an intricate task. Luckily, we have technology solutions that help simplify and help these tasks be easier for your business. And I think the software solutions do play a very pivotal role in easing that accreditation process for calibration labs. So really my question is, how do software solutions assist labs in achieving and maintaining calibration and accreditation?
How much time we got?
Uh,
No, I'm joking. So I will enforce my first turn here as the software guy in the room. So I think that, you know, when we look at design software within calibration, and really software anywhere, right? We're trying to address a value to that user, and we've talked about, right, how complex and how tedious some of these activities can be related to accreditation and maintaining that quality. And so the more of that workflow, the more of that like quality check and confirmation of that quality system that we can enforce automatically, the better off we're going to be. One, just from ensuring that we're actually meeting it and making it much easier to pass our audits, but two, enabling us to expand, right, and have our metrologists spending their time working on things that you want your metrologist working on, and not sifting through a bunch of analysis to figure out, you know, what was impacted by your out of tolerance condition. So I think really the role of software within this is to take on the brunt of this effort and reduce the load on us as humans. And as we continue to, you know, go through and move into the AI era here, we'll see more and more of that as we find ways to enable those types of tools to leverage and use in these areas. In you know, a host of different existing tools, and obviously I'm not at all biased toward Met Team and MetCal or any of that. But what we're really seeking to do here is run these types of processes just in the background, so it's not even a second thought, and making sure that from our perspective, right, we're enforcing those effectively, and also giving enough flexibility on the user end to be able to enforce their own rules, and ensure that those specific things about their workflows are also meeting their expectations.
You know, Michael, one of the things that I've always talked to folks about when we get to this software discussion, folks immediately jump onto the labor savings for automating things, or I can set this thing up and have it being performed by the software and the computer and walk away. And while that is a great way to think about it, probably the thing that I've always tried to stress to folks that automation is only one of the benefits of doing something like this. The real thing that I've always tried to tell people is what software also does is it forces consistency.
Yep.
And when we talked about earlier, say what you do what you say. If you have a process that's automated through software, you will be forcing folks to do a consistent job. You won't be skipping a point because, oh, I just missed it today. It's written into the procedure. So one of the significant benefits of going to a software offering or a product isn't just the automation, but it's that consistency. And you can take now I can take two sets of results on two different instruments, knowing that they were performed the same way, and that the operator probably didn't have a very significant impact on what those results are. It makes the results more comparable. It allows you to understand more about what other things are impacting. You can start seeing things where maybe the environmental conditions were different. But all of that stuff really pushes towards what you can do, or one of the benefits of automation or software products is, in my mind, it's really driving consistency into your processes.
Yeah, and to kind of build on that, you mentioned automation is a pretty small piece there, and if you think about the complete workflow of calibration in a lab, right? How much of that is actually doing the act of calibration? Like time-wise, it's a very small piece. Even on complicated procedures that are running 8, 16 hours, that piece is going to be in the lab for a week, right? And so what's happening in all that other time is not at all impacted by an automated test procedure. And so there's so much opportunity in those other areas to focus on and go beyond just the automation of the calibration process itself. And certainly that's a huge area, and for more complicated things especially, you see a much bigger impact on that, right? Calibrating a 4-channel oscilloscope automated has a huge impact time-wise. Calibrating a caliper in an automated sense, much less so, right? It's shorter cal, a lot less steps, and you end up doing a lot of that manually anyways. But because you're having that consistency, like you mentioned, because you're having that uniformity of approach, right? We're storing all our data in the same place. We're able to do analysis of that data in a broader sense when we're able to do that. All of that kind of comes as a side benefit out of that, and being able to address much more of the workflow than just the calibration itself.
Yeah. But going back and sharing a little bit of the history of the standard. So back in 1999, when the first version of ISO 17025 came out, computers were still a relatively new thing out there, and there were still a lot of people that hadn't embraced that technology. So the way the standard was written was kind of assuming that you were going to do a lot of processes manually, and maybe once in a while you might use a computer for something. And of course, that's completely flipped around, where today we use computers for workflows on almost everything and rarely do things manually. But so I'm still a big fan of the automation part of it, because back in the old days, we used to have to do things by brute force, to be able to get these things done. For example, and I'll say even something as simple as filing a calibration cert. Today, you push a button and it's electronically stored on your system in MetTeam, and you could push a button and retrieve it, and there it is, and it's readily retrievable, and you're there in a second. In the old days, it was physically put it in a file cabinet somewhere, and then if somebody called you back, you'd have to walk to the file cabinet, pull it out, and go out and get it. So it would take 15 to 30 times more time than it takes today. So I'm loving the automation, because it allows us to put more time and energy into the things we love to do, like calibration. But I had a manager back in the day as well that, to Michael's point, he brought up a really good point. My manager would say that the average hours per unit is about 2 hours of calibration time per unit. If you aggregated it over the thousands of units we do, if it takes 2 hours to service a unit, why does it take 2 weeks to get it in and out of this building? And like Michael was saying, it's all those other things that we were talking about. Now that being said, now sharing a little bit about the insides of today's and interpreting the standard. So when we wrote the 2017 version of ISO 17025, we tried to be as technology agnostic as possible, not to say computers will do this or computers will do that, and focused on process. So understanding that there may be a different system technology that we haven't thought of today that we need to address, out of that process. So it's like I said, we want 17025 to evolve with the laboratories, not use the first version talked about facsimile machines and telex, which is really old technologies that nobody uses anymore. We got rid of that just to say think about process.
Yeah. Yeah, I think today's been a very excellent discussion, really, on understanding what accreditation is. Hopefully, we have demystified some of that, what ISO 17025 really is, and really how software can help support your accreditation process. But before we wrap up, really wanted to kind of hit on some questions that we received from the audience here. The first one is, at what point does ISO 17025 accreditation become mandatory on the process level? And how does it differ from being compliant? So it's like the customer really doesn't mandate 17025, but when does it become mandatory, and how does it differ from being compliant to ISO 17025?
Anybody want to start?
So first of all, I don't think ISO 17025 ever becomes completely mandatory. It's a voluntary process. What does drive people's, where they go with that is the customer and their expectations of what they need for their quality system. So, if you have a lot of, if your customers are requiring a lot of, you have one customer that does it, it requires it not so much. But if you have 50 customers or 100 customers, then you start saying, well, maybe I don't want to lose that business. So again, it's really a commercial justification, as I said when we started out. And again, it's not a mandatory process.
It's interesting to me too, because a lot of the requirements in 17025 are very customer driven, right? It's about, that agreement with your customer about that contract and what's in there. And so it is fitting that, the requirement to have ISO 17025 accreditation really does come from the customer in the same way.
Yes, but it's important to understand as well, though, that once you make the decision to be accredited to 17025 and not just compliant, I mean, anybody can comply with 17025. That's your right, and if that's what's driving you, great, just comply with 17025. But if you're required to be accredited, then it goes down to as simple as process any place where a measurement is being made. When we revised 17025, that was one of the guiding principles, to make sure that the document was something that could be done by a one-person organization just as well as a 100-person organization, to make it scalable up and down for size of organization, but also for types of processes. So you could do accredited calibrations whether you're calibrating a torque wrench in a machine shop or doing the simplest measurement in a process manufacturing line, or you could do it in the highest level measurement laboratory as well. It applies everywhere. Anywhere where measurements are made, 17025 can help make you a better process. But it also is flexible enough to move those requirements up or down, as well. You don't have to spend hundreds of hours doing an uncertainty analysis for a simple process measurement when a 5-minute estimate will be quite adequate for that process as well. So make sure it makes sense for the application that you're doing.
Yeah. Another question that we received is, when using OEM calibration procedures, is it a requirement in 17025 to keep calibration procedures up to date against the OEM procedure library? How does softwares like MetTeam help automate that process?
Michael, you want to start with the MetTeam part of it, or?
No, I want you to start with the other piece to make sure I'm not crazy.
I want to pull up the actual 17025 to make sure that let's look at the actual requirements of ISO 17025. So that'll take me just a second here.
So Jeff, while you're doing that, so one of the things is first of all, I don't think ISO 17025 requires you to follow the OEM's recommendations. They want you to follow the procedures that are important to your customer. Not, those might be the OEM recommendations. In fact, many times they are, but I don't think the ISO says anything about what procedure you have to follow. I mean, in terms of the points that you test, the equipment that you use, they do have there are other requirements, other ways of stating that are not so prescriptive.
Well, so I've got the standard up. So let's kind of walk backwards a little bit on that to hopefully answer this question. So first of all, it says when the customer doesn't specify the calibration procedure. So the customer also has a hand in this, because they're sending you a piece of equipment to get calibrated. They may want it calibrated in a very specific way, but when the customer doesn't specify it, the laboratory shall select an appropriate process and inform the customer of the calibration procedure that you've chosen. So, and it does say methods published either in scientific texts or journals or specified by the manufacturer of equipment are recommended, not required, but recommended. So it does say use that. Now, we're backing up to the previous version, 7213, the previous requirement is the laboratory shall ensure that it uses the latest valid edition of a method, i.e. procedure, unless it's not appropriate or possible to do so. And how we interpret that is okay, yes, if you're using an OEM manual, you should use the version that is applicable to the product that you're calibrating. So if the latest and greatest revision of the procedure is right for your product, that is what you should be doing. But remember that there's also times that that's not appropriate or not possible, because it could be that, say, model 123 has a serial number break at 10,000. So if you've got a serial number of 9,800 and the latest version is for a rev for version or serial numbers 10,000 and above, it's not appropriate to use the newer manual. You want to use the older manual that fits the serial number series for your product. But you know, good practice is to try to use the latest appropriate and valid edition. So I hope that kind of answers the question for the person asking.
Yeah. So on the software side of that, you know, it's really about making sure that what you have is documented effectively. So in, you know, MetTeam and applications like MetTeam, you know, you have the ability to keep track of what the revision of that procedure is that you've put in there, and that could be a, you know, template that's built upon a certain revision of that manual, or it could be a Metcal procedure that was based on a specific version of that manual that's annotated inside of that procedure. Well, now we know the build, you know, the publishing revision date of that procedure, and there may be a newer version of that. So it really comes down to ensuring that we're documenting that, and then periodically having reviews and checks to go back and ensure that there isn't something newer. When we develop a Metcal procedure, we have over 18,000 now. So we don't always know when there's a new version of that, but that's why we have warranted procedures. So if you point out, hey, there's a new version of this, we'll update that procedure and make the new one available. That's kind of the way to approach it there.
AI, Michael.
Yeah, so
AI,
so
all the things.
Yeah, so today we really looked at what the accreditation process is, how do the governing bodies affect accreditation, and how do you ensure continued compliance with your laboratory, and really dove a little bit into the software piece as well, which helps aid in automating the entire accreditation and calibration process for your laboratory. I know we didn't get through all the questions. There's some great questions here. We will be following up with the FAQ here shortly, answering your questions that we didn't get to. I do want to thank everyone here for attending and their participation. Please reach out if you have any other questions. We'll be sure to get back to you in a prompt manner. And obviously, come see us at MSC here in a few short weeks at the end of March. Again, appreciate everyone's attendance and their participation. Have a great day. Thank you.
And Mir, before we jump off, could I also say that some of these questions might have been answered in my weekly blog post, Metrology Monday, on LinkedIn. So, and if you have some good questions out of this that need an expanded answer, I may use those as a subject for further posts as well. So if you don't already look at that, that might be something as a resource to help you as well.
Yeah, awesome. Thank you, everyone. Thanks for attending.